Hello everyone. For me it is a good morning, but good afternoon or good evening wherever you are, whenever you may be watching this. Again, thank you for tuning in. Thank you for your dedication and time. I'm not sure how many of these videos you've watched, but if you've watched from the beginning, you have been in for a lot. So we're going to pick right up where we stopped. For me, I stopped yesterday. I think where we left it was on the WAN routers. We had done nothing more than establish a basic EIGRP peering over our newly created DMVPN topology. So we should be able to verify that by show IP EIGRP neighbors on the branches, and we can see that yes, in fact, it was almost exactly 1 day ago when I did this, and we see that we have 4 peerings over the tunnels, right? So we're going to go ahead and we're just going to start establishing EIGRP adjacencies kind of across the board here. So we're going to want to advertise our EIGRP routes that we have on our switches, the various VLANs that we have in Site A, same thing in Site B. And since we have our EIGRP peerings back to the WAN routers, the hope is that they start to learn about those subnets and, like I said, trickle them down into or advertise them down to the cores. The cores are going to want to advertise the VLANs that we have in the data center, and essentially what we want to do is just get all of those routes in the EIGRP table and see what changes or metrics we need to adjust or play with to prefer these routes. So we can start at the data center or we can start at the branch. It doesn't really matter. I guess we'll start in branch A, site A, and we'll see how far we can get these routes, and we'll just take it one step at a time. So all that being said, let's look at, first and foremost, let's check our routing table as it stands now. So right now there is a whole lot of nothing as far as EIGRP routes go, which is interesting, right? Because when we do show IP EIGRP neighbor like we just did, we have 4 neighbors, and we know that we're peering over the various /30 links, /24 links, all of that. So the question is, why are we not learning any yet? Why are there no EIGRP routes in the table? There's a command we can run, show IP EIGRP topology, and this is interesting. So when we run that command, we can see a whole bunch of stuff, right? We can see that we have those 192s that I was just referring to. We can see that, that's the 10.101.254. That's in the data center. We see all of these routes, right? 10.100/22. That's actually belongs to the site A. But the question is, why is none of this stuff ending up in our table? It's because the BGP metric, or I should say the AD, the administrative distance, is 20, okay? So all of these routes are administrative distance of 20. EIGRP is going to have either 90 or 170, depending on whether it's been redistributed in or locally originated via the protocol itself. So that's why. So BGP is beating out EIGRP. So this is something we need to be aware of in our particular case, right? Because we're coming from BGP and we're trying to go to EIGRP. So before we start monkeying with any of that stuff, let's just get everything squared away as far as our network statements and all that stuff goes. So show run section EIGRP. The only thing we have on this router is the 2 network statements for the DMVPN, okay? If we show IP interface brief, we have a peering going down to switch 1. So, we're going to want to incorporate that. Let's hop on switch 1. Show IP interface brief. So here we have 3 VLANs, right? So we're going to want to obviously get those in some instance of EIGRP as well. So 10.101, 10.1.0.11. So we should be able to build the peering over that link. So show run section EIGRP. So let's get that for starters in EIGRP. And that is what? What's the subnet on that? It's a /24. So under topology base, we are going to advertise, or we're going to put in, sorry, not under topology base. We're going to go under network 10.1.0.0 with the wildcard mask of 0.0.0.255. Okay. Do show run section EIGRP. Okay, we have that in there. Now we're going to go to the switch. Do we even have EIGRP defined? No, we do not. Show IP protocols? No, it's not there, right? So we need to define EIGRP. So we're going to say EIGRP AS65001 because we need to keep with that. And we're going to say network basically the same statement. And we can see we've got an adjacency now, so that's good, right? So do show IP route. Okay, so now we're starting to see a couple EIGRP routes. So now from the switch perspective, okay, we have the tunnels. We're starting to see some stuff kind of pop in the EIGRP table, or the routing table, if you will. So let's go to switch 2. Show IP interface brief. So we have an IP address on VLAN 100, which is awesome. So let's go ahead and get that peering built. And honestly, we should be able to take this entire config and blast it on switch 2. Cool, so we got some neighbors there, show IP route. We still have this static, which we're going to have to obviously deal with at some point in time, because we're going to want to strip that out. But for now, we've got our peerings. So on switch 1, we have a couple more things we have to do. So we have VLAN 200 and 300 that we need to kind of cope with in order to make it complete. So we're going to get the network statements in for 10.1.1.1, 0 wildcard mask 0.0.0.255, and then we're also going to do 10.1.2 to accommodate VLAN 300. In this case, we didn't build 400. It's in the key, or it's in our topology, but we never actually built a VLAN 400, so we won't worry about that. All right. And in this case, we're actually building the individual /24s as opposed to the /22, which is what we did in BGP. All right, so we probably are going to want to do a redistribute, connect it into EIGRP, but let's come back to that. Right now, we're just going to do network statements and build peerings, okay? So on router 1, let's see what its table looks like. So it's obviously growing. Show IP route EIGRP. Okay, so nothing's there, right? It's the same story. It's because BGP's beating EIGRP. So I don't want to get rid of BGP just quite yet. I want to leave it kind of the way it is. So let's come down to WAN router 1. Show IP route. Let's do a show IP route EIGRP. So we are, what do we have here? So we have a default that we're learning. We have nothing more than what looks like to be the data center stuff, at least as far as I can tell. Show IP route BGP. You know, again, it's most likely because we're dealing with the metrics and stuff. So let's do this. Let's go to the cores. And the reason I'm doing this for a reason. I'm not blowing away BGP yet because I think I can make a point here. Show run section router. Okay, so we are redistributing static for EIGRP, which show run include route. That's basically the default. So that's where that default was coming into play. So that's this, okay? So that quad 0 route is being learned because of the redistribute static and having the static there. So that's where that's coming from, right? Show IP interface brief. So we need to incorporate right now we're only doing EIGRP, I believe, on those two links. Show IP EIGRP interfaces. Yeah, so this is a nice command to use. Show IP EIGRP interfaces tells us that we're only running EIGRP on ETH 1 and ETH 1.3 and ETH 1.4. When we look at our show IP interface brief, we can see that that means we're only incorporating these two subnets in EIGRP. So we need to get all three of these. Okay, so let's go ahead and tackle that. So we're going to come into interface VLAN 101, and if we cheat, right, basically we just want to do this command on the VLAN interfaces. And we're going to say no passive. Can we do, what do we want to do here? We want to do, did I do it on, I think I might, we want to say no IP router EIGRP, or we want to say passive. We want to make it passive, sorry. I don't know why I'm having a brain fart here. I know we did this somewhere. Where did we do it? Yeah, that's what we want. We want to do the same thing we did on 254. Because we don't want to build adjacencies between all the VLANs. We only want to build adjacencies between the actual links themselves, right? We don't want to try to build adjacencies on top of those links, which is the VLAN interfaces. We don't want to do that. So we want to basically turn off the hellos and all that stuff. So let me, because we're going to want to do this on both cores. So let's split the window, and we're going to do both cores at the same time because they all share those VLAN interfaces for HSIP, right? So right now we're focused on 101. So that looks good. So we're going to do these two commands on 101 over here. Then we want to go into 102 on both cores. And we essentially want to do the same thing. And then 254 is already done. Yeah. Good. So now, if we go back to the WAN routers, let's split those between the windows. Alright, so we've got EIGRP running on 3 and 4 and tunnel 0 and 1 on both WAN routers. We are learning considerably more routes on WAN 02, or at least they're being injected into the table, I'll say. So if we do show IP EIGRP topology, So you can see it looks like we have the majority of the routes on WAN 01 in our topology table, right? So that looks to be the same, very close to. However, they're not making it into the routing table on WAN 01. Because we're still kind of competing with BGP. So, and that's fine, right? That's fine. Let's go back. So at this point we have adjacencies between the cores and the WAN routers. We didn't do anything between the firewall and the WAN routers, did we? That's the 254. Let me look at the firewall real quick. Show IP protocols. Yeah, we're not doing anything there. We can talk about that, but we're not doing anything there at the moment. So that's fine. Let's get site B done. I already have a connection up to them. So we're doing router on a stick here. So the show run section EIGRP. Yeah, so we defined it for the tunnels, but now we have to incorporate all the network statements actually on this router itself, because that's where those gateways live, right? We did it a little differently between the sites as a demonstration. So what we want to do is come under the EIGRP process here and essentially do 10.2.0.0, hit the up arrow and just do 1, 2, and 3. That should cover all 4 VLAN interfaces or sub interfaces on this router and stick them under EIGRP. Okay, so they're all there. So I believe with those network statements, I believe that builds our EIGRP topology table end to end as far as what we want, right? Now we can start to break or undo BGP one site at a time. And we'll see if the routing table updates. Quite frankly, like we wouldn't even lose connectivity because we're just replacing what we already have we're just injecting the topology table into the routing table, which is effectively replacing BGP. But we shouldn't even see loss of connectivity, which is kind of a nice way of doing it this way. So let's come back to site A, router 1, okay? And we'll show you what I mean. So show run section BGP. The other thing we can do, this was what I wanted to kind of show you at the end of the DMVPN stuff. So if we go to WAN router 1, I don't know why I keep opening these things again. If we come back to WAN 01 and we do show run section BGP, we're advertising network quad 0, right? Let's go ahead and, first of all, let's get rid of the redistribution command. Because we've layered EIGRP on top of what's already there, which used to be the BGP underlay. So we don't need that anymore. Okay, so we're going to get rid of that. Let's do the same thing on WAN 02. So we're going to get rid of the redistribution. Now the same thing should technically be able to happen the other way, because we did mutual redistribution, right? So do show run section EIGRP. See, we have the redistribution for BGP into EIGRP. So let's get rid of that as well. We're breaking that mutual redistribution. So let's come under topology base on both routers, and let's get rid of that statement. Okay. All right, let's go back to site A, router 1. Let's check our routing table. In fact, let's do a clear IP BGP star soft. I'm going to bring site B, router 1 over to the other side. I want to just look at both branches perspectives. Let's clear IP BGP star soft. Show IP route. Show IP route. Okay, so we still have all these BGP routes. Let's go back to the WAN side. Let's take that network statement out. We're taking out the network quad 0. Oh, I checked this out. Okay, this is a good lesson. So this is a really good lesson, actually, because if you don't verify, you can have an adverse effect. This whole video is probably worth it just for this. So let me scroll up. So we're looking at the BGP configuration, okay? If I scroll up here, I came in router BGP, and I thought I took off the redistribution, okay? Which I did. I said no redistribute EIGRP and then blah, 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 right? I did that on both boxes right here, all right? But then when you come back down here and you look under BGP, it's still there. So the only thing that no statement did was take the metric keyword off. That's all it did, which is a good way to burn you, okay? So if you don't verify that you've removed the entire thing, you're going to waste hours of your life, okay? So I'm actually glad I'm glad I'm just winging this video, because this is a really good lesson. So let's take off the network statement like we wanted to. Let's hopefully finally take off the redistribution. All right, let's go back to our branch sites. Let's hit the up arrow. Okay, let's clear IP BGP star soft on both. Okay, we're still dealing with a bunch of BGP routes. Show run section BGP. So we need to get rid of this statement now, all right? So that's why I wanted to do this in steps, so you can see everything we need to kind of undo. Yeah, we have both the network statements under the branches, and we have redistribute connected as well. So we gotta take all this out, right? So we're going to take this network statement out. On this side, we're going to take out the redistribute. We're going to take out the network. All right. So the only thing we have really is just the neighbor statement. Right? So we're not advertising anything into BGP from site B. From site A, let's just verify again. Same story. We're not advertising anything into BGP. We still have the ability to learn what's in. Did I say BGP? BGP. I think I said BGP. Do show IP route. So look at that. It's starting to look better, right? Now what we can see is, and this goes back to a comment I made either a video or two ago, where I said we might have to definitely muck with some of the metrics, because what we're seeing here is ECMP at its finest, equal cost multipathing. So EIGRP will do ECMP out of the box, and when we built these tunnels, so if we look at tunnel 0, for instance, it has do show run interface tunnel 0. They all share the same delay, okay, and they all share the same bandwidth. So if you recall your EIGRP metrics, it basically determines the two that matter are kind of bandwidth and delay. And it just so happens that the way we built this, they're all the same, which is going to give us ECMP because they all share the same metric values. So that's going to be something we're going to want to try to tweak or mess around with if we want to favor one direction versus the other. Right now, all we're kind of focused on is just getting the routes in the table as far as EIGRP goes, which it looks like we're accomplishing that. We're going to get rid of the static route too, because I want to make sure that we don't want to get rid of that yet. I take that back. So that's going to be important for our direct internet access. So we're going to leave that for now, actually, now that I think about it. Okay, so let's see if we can get some connectivity tests just to verify that this is doing what we want it to do. Let's hop on server 1. He hasn't been rebooted in a long time, so let's reboot him. Let's stop server 1. I'm not even going to look at PC3. Let's just stop him. Server 1, PC3. E01 was show run interface E01. All I'm doing is getting my bearings. I gotta slap these IPs back on there. So on switch 2 in site A, ETH01, that's what I'm looking at. It's VLAN 300, so he needs to be in VLAN 300, which is 10.1.2, and I think we're using 13, and the gateway was it 1 or 254? 10.1.2, switch 1. The gateways are 1. So he should be able to ping his gateway. Okay, good. Baby steps, right? Baby steps. And then we need to go back to server 1. Was it server 3? Which one did I reboot? Server 3. Yeah, there we go. We need to see what VLAN he sits in. So 1.3 off of top of rack. One 3 off top of rack was VLAN 101. VLAN 101. So he gets IP 10.101.101.13. And these gateways were 254, I believe. No, they were .1. Wait, hold on. Show run interface VLAN 101. Yeah, 254 is the HSRP address. 10.101.101 254. Okay. Okay, finally. Jeez. So PC 3 and server 3. Let's see how bad we broke it. So it's working. So that's good. Let's see what the traceroute shows. Yeah, it's not bad. So it looks like it favored tunnel 1, which is fine. Yeah, this is actually kind of cool. So I do think it's worth the conversation. We can kind of play with some of the delays and bandwidths in the next video. But I think, I think I got the point across as far as now we don't have to deal with all the redistribution and all that stuff. So let's just summarize and we'll end on the summary. So if we start at the, let me close, I'm not going to close anything. Let me open the firewall, because this is where the routing boundary between static and we'll say BGP out to the internet happens as far as the default route goes. And then everything that's on the cores is just immediately advertised via EIGRP into the routing domain. So if we look at the firewall, show IP route, this is where we have the static route that goes out to the internet, and we have a static route that goes to the inside. So that's a routing boundary. We're not participating in any protocols on this firewall, okay? When we go to the core switches, so if we look at core 1, show run include route. We have the route that says if you want to get to the internet out of the data center, go to the firewall, which is exactly what we're staring at here, okay? However, there's no routes for any 10 dots because we're advertising those with EIGRP at this point, right? So show IP EIGRP interfaces, we should see that we have 1.3 and 1.4. They show up because they're not passive, okay? But if you look at show run interface VLAN 101, we do have the advertisements in EIGRP. However, the passive interface is there, so we don't neighbor with anybody else that has that subnet, okay? So it could be misleading when you run the show IP EIGRP interfaces. You're kind of getting, you're not seeing the full picture, right? You're seeing 1.3 and 1.4 because they're the peerings going to the WAN routers, but you're not seeing the VLAN interfaces themselves. So get in the habit of double checking and running a couple different commands. But once we put those in EIGRP, right, they're now going to be advertised over to the WAN routers. So if we take it one hop at a time, if we go to the WAN router and we check our table, show IP route EIGRP, we're learning the 10.101.101 via those ETH 1.3 and 1.4 addresses that or interfaces that we just looked at, right? That's how we're learning them. We're learning them over the peerings between core 1 and core 2, like I'm highlighting here. So core 1, core 2 originate those routes in the EIGRP. They're learned by both the WAN routers. The WAN routers have the tunnel peerings, show IP EIGRP neighbors. So they have all 4 tunnel peerings, like I have highlighted here, which send the 10.101.101 advertisement over the tunnels out to the branches. So when you get over to the branches and you check the table there, show IP route EIGRP, we learn about 10.101.101.0, but now you can see we're learning it from 4 different places because we have 4 tunnels going back to the data center, okay? And this is where we may want to introduce some tuning as far as like, hey, do I want to favor MPLS more than I want to favor the internet, or do I want to favor the internet more than I want to favor MPLS? that's decisions you need to make based on your specific environment, right? Maybe you want to take advantage of the QoS over the MPLS side of the house because you know that they offer that SLA or the QoS. The internet might be more useful for a backup, right? Give the employees the direct internet access because it's more efficient in that regard. But as far as going back to the data center for workloads and applications, maybe it makes sense to use the MPLS for those particular flows. I'm just trying to make points on how you want to think about, tweaking your environment. But I'll stop there. That was a lot to unpack. We essentially got rid of BGP for the most part on the WAN side of the house. We completely replaced it with EIGRP, as we can see. Yes, we're still going to see, let's maximize this. We still are going to see a couple BGP routes floating in and out, right? Those are the transit networks that get from our site to the service provider or whatever. So you will see a couple of those, but we're not taking advantage of them. We're not using those. All the routes that we're starting to care about are going to be learned over the various tunnels, okay? So that was kind of the point I wanted to stress on this video. I know it was a long, convoluted way to get there, and I jumped around a lot, but hopefully I vocalized it enough to kind of get the points across where I thought were important. So we'll stop here, probably do one more video with, maybe some of the metric tweaking and stuff like that. Maybe we can try to do some route filtering as well. Maybe we don't. Maybe we want to clean the routing table up a little bit. We can talk about some of that stuff. So I'll stop here. I hope you guys enjoyed it, and I will see you on the next one.